Okay, the second time series method that we're going to discuss is moving average forecasting. It further has two types of simple moving average and weighted moving average. Simple moving average is generally used where we have stable demand with no pronounced behavioral patterns, so only random variations are there in the data. It uses several demand values during the recent past to develop the forecast. So it is also one of the short-term forecasting methods. The average value over a set time period, for example, last 4 weeks, is uh, taken. Each new forecast drops the oldest data point and adds a new observation. So that is why it is called moving average forecasting. In simple moving average, we give equal weightage to each data point, each value of the actual demand in the past that we have. But in weighted moving average, we assign different weights to demand of recent periods. So we will first see simple moving average. These methods use moving averages for specific periods such as 2, 3, 4, 5 months. If the variation in the variable remain reasonably constant over time, a large n is recommended. Otherwise, if the data exhibit change patterns, a small value of n is recommended. Now, these 2 points are really important, and we will explain these points with the help of an example, but I will read them again that if there is a lot of variation in the data, then small n is recommended. And if the data, the past demand data is reasonably stable, then a relatively large n is recommended. And we will see why. So this is the simple formula for the average. So we add the actual demand for the certain number of period divide by n. So this is the formula for average that you have been using. So the point that I mentioned on the previous slide that the more the variation in the demand, the smaller should be the n. So let's explain it with the help of some data. So this is the demand pattern that we have for a certain product. Now, if we use a small n is equal to 2, you can see that the forecast very well responds or reacts to the changes in the demand. So these are the points for the actual demand and these are the points for the forecast. Now, as we increase n or the number of periods, for example, if we make them 5, if we take the average of the previous 5 months demand, then you can see that the forecast, this line, something in orange color, that is the forecast, does not react to the changes in demand the way it did when n was small, that was equal to 2. And if we increase the number of periods further, say we make n is equal to 8, we take the average of previous 8 months demand, then you can see that the forecast even less responds to the changes in the actual demand. So in simple words, in this case, smaller the n is, the more accurate is the forecast, and the greater the n is, less accurate is the forecast. We will further see this with the help of the data that we are discussing for our calculations. Now, if we take n is equal to 2, so that is simply taking average of previous 2 months data. So we will take average of January and February. So you can use the function of average or simply add these two values and divide by 2. So that will be the forecast for March, and you can simply drag till December 2019 in this case. I'm not going to make the rest of the calculations for error and absolute error. You can make those calculations later because we have learned those formulas. And if we take n is equal to 5, so we will be taking the average of first 5 periods. So from January till nothing new here, just number of periods have been increased. And again, you can calculate the error and absolute error, error squared and absolute percent error, and take their average to find MAD, MSE, and MAPE. I'm just going to compare the results of the two forecasts using 2 months and using 5 months. So these are the results. So once we used 2 months moving average, so we got these results: MAD of 7.2, MSE of 100.5, and MAP of 8.3%, and standard deviation of 19.2. And these are the results for forecast using 5 months average. So you can see the values. I have shown them here side by side to make a comparison. So if you have a look at the chart for 2 months simple moving average and 5 months, you can see that for 2 months the forecast very well responds to the changes in demand, more accurate. But if you have a look at the 5 months moving average forecast, so you can see the bigger difference. So this difference is actually the forecast error, the difference of actual demand and forecast for a specific period. So this seems to be bigger value than we had here in the case of 2 months forecast. And if we compare the numerical values, you can see that MAD using 2 months average forecast is 7.2 and it is 9.8 for 5 months. And other values like MSC and MAPE are also smaller for 2 months forecast than they are for 5 months forecast. So what conclusion do we reach is that MAD is smaller for 2 period forecast, 7.2, as compared to 5 period forecast, that is 9.8, showing that 2 period forecast is more accurate, have smaller forecast error. On the other hand, the standard deviation is larger for 2 months forecast and it is smaller for 5 months forecast. So this is the standard deviation of the values of the forecast. So that means that the values of the forecast for 5 months method are much closer to each other than they are in the case of 2 months forecast. So that is something that we do not require. We do not require the forecast values to be closer to each other, but we require them to be closer to the actual demand. So the forecasts are less smoother for smaller n, they are more smoother for larger n, but we need the forecast to be responsive to the changes in demand instead of forecast values to be closer to each other. I hope this point is clear. If it is not, then you can ask.